Alright, you guys, so we are here with Unit 2A review. I'm going to work the evens of page 1 and 2. So at number 2, it says, what is the parent function? And we've been through this several times. You always want to write the parent function as y equals x. And that means that whatever the value of x is, y is going to have the same value, and vice versa. So that means if I was going to make a table of points, whatever value I plug in for the x, y would be the same value. So 0, 0. If I plug in 1 for the x, then y is 1. If I plug in negative 1 for the x, then y is negative 1. And you can graph this using those points, 0, 0, 1, 1, negative 1, negative 1. And if you continued your table, you would see that the line extends from those 3 points on with a slope of 1, up 1 over 1, and going straight through the origin. The next thing it asks is what happens if you apply a negative? Well, that would mean that y equals a negative x. And the way you can think about this is y is the opposite of x. So if I was going to make a series of points for this equation, if x is, I don't know, 0, negative 0 is still 0. But if x is 1, then y would be a negative 1. And if x is negative 1, and you plug that into your formula, y would be a negative negative 1, which is really plus 1, or positive 1. So what that's going to do, I'm going to try and graph this in purple so you can see it a little better. This line still goes through the origin at 0, 0, but then 1, negative 1 is right there, and negative 1, positive 1 is right there. And so what you see is that this, when you apply that negative, it just changes the slope of that line. Instead of having a positive 1, now it's a negative 1. So y equals negative x. And this is the original parent function. Moving on to number 4, we are given the function y equals 2 over 3x plus 1. Complete the table and graph the function. So what you want to do is plug in each one of these x values into our function and then figure out what they equal. So for the first one, y equals 2 over 3 times, I'm going to plug in the negative 6 plus 1. And you can put that in your calculator if you wanted to, or you could do the math in your head. 2 times a negative 6 is negative 12. Negative 12 divided by 3 is negative 4. You get negative 4 plus 1, which is negative 3. So that first range value is negative 3. Then you would want to do that same thing for the next equation, or for the same equation, but for the next x value. Plug in 2 over 3 times a negative 3 plus 1. 2 times negative 3 is negative 6. Negative 6 divided by 3 is a negative 2. Plus 1 is a negative 1. So that's my next range value. You would continue this to find each range value. 2 over 3 times 0 plus 1. 2 over 3 times 0 is just 0. 0 plus 1 is 1. Y equals 2 over 3 times 3 plus 1. 2 over 3 times 3 is 6 over 3, which is 2. 2 plus 1 is 3. And then lastly, y equals 2 over 3 times 6 plus 1. 2 over 3 times 6 is 4. 4 plus 1 is 5. So now I have my range values. Remember, Dr. IV x, y, I, O. All of your domain are the x values. All of your range are your y values. So my whole range set is right here next to the y. You always want to list that in set notation with those squiggly brackets. We've got -3, comma, -1, 1, comma, 3, comma, 5. My next job is to graph it using these points. -6 is right about here. -3 would be here. -3, -1. 0, +1. 3, 3. And 6, 5. Be right out there. You want to connect those. Okay. So that's number 4. Continuing on to page 2. Number 6, we're still graphing, but this time it wants us to use the x and y intercepts of this function in order to graph. So if you remember, when you're looking for the x-intercept, you plug in 0 for y, and when you're looking for y-intercept, you plug in the 0 for the x. So I'm going to start with my x-intercept, which means I want the x to stay in the equation. And then instead of the y, I plug in a 0. -3 times 0 is 0, so you're just left with the 9x equals 9. From there, you divide by 9 on both sides, cancel, and you get x equals 1. Don't forget to write this as a coordinate point. X is 1, y is 0. My y-intercept, I plug in the 0 for the x value. 9 times 0 is 0, so you're just left with -3y equals 9, and then you divide. Divide by -3, divide by -3. Cancel. Y equals -3. Don't forget to write this as a coordinate point. So my x-intercept is 1, 0. My y-intercept is 0, -3. And then we'll graph. 1, 0 is right there. 0, -3 is right here. And then you'll connect those dots. Same thing for number 8. It says graph the linear equation by finding the x and y intercepts. So in order to find the x-intercept, you're going to plug in 0 for the y. And in order to find the y-intercept, we plug in 0 for the x. So 2x minus 0 minus 8 equals 0. Well, minus 0 minus 8 just comes out to a -8, so you get 2x and a -8 equals 0. And you want to move all your whole numbers over to the right so I can solve for the x. So I'm going to add 8 to both sides. 2x equals 8, and then divide by 2. So x equals 4, and remember to write that as a coordinate point, 4, 0. The y-intercept, plug in 0 for the x. So 2 times 0 minus y minus 8 equals 0. 2 times 0 is 0, so you're just left with -y minus 8 equals 0. You can move that 8 over by adding 8 to both sides. You get -y equals 8. Not quite done though, because you got that negative right next to the y, so you want to divide by -1 on both sides. You get y equals a -8. You want to write that as a coordinate point, 0, -8. And then you want to graph 4, 0, and -8, 0. And he would be back down there. So I'd recommend either you estimate it pretty closely or change your graph to have a scale of 2. That is is it for the evens for page 1 and 2. Hope that helps. Come into tutoring if you have any questions.